Please put your attendance in the comment window. Okay, in the last class we have discussed Rankine formula and how that is important for a column and thread. In a column and thread, we have Euler's formula. Even though Euler's formula is available, we are deriving another equation that is Rankine's formula. Normally, Euler's formula are valid only for long columns. So, we cannot apply Euler's formula for short column as well as medium column. That's why we are deriving another equation that is Rankine's formula, actually not derivation, it's an empirical equation, and that is a connection between Euler's crippling load as well as crushing load. So you have known the equation and final term also known to you as we have discussed in the previous class. So directly we will go to a problem. So please write down the problem. That is a hollow cylindrical cast iron column. Please write down the problem. A hollow cylindrical cast iron column. A hollow cylindrical cast iron column. A hollow cylindrical cast iron column. 200 outer diameter. 200 outer diameter. 200 outer diameter and 150 inside diameter. 150 inside diameter. Comma 4 meter long has 4 meter long has both ends fixed. 4 meter long has both ends fixed. It is subjected to an axial compressive load. 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 Taking the factor of safety as 6, taking the factor of safety as 6, taking the factor of safety as 6, comma, crushing stress 500 Newton per mm square, crushing stress 500 Newton per mm square, comma, Rankine's constant 1 by 1600. Rankine constant 1 by 1600. Then determine safe Rankine load. Safe Rankine load. Then determine safe Rankine load. Hope you have written the question. I will read the question once again. A hollow cylindrical cast iron column, 200 meter outer diameter, 150 inside diameter, 4 meter long, has both ends fixed. It is subject to an axial compressive load, taking factor of safety as 6, crushing stress 500 Newton per mm square, Rankine constant 1600, 1 by 1600. Determine safe Rankine's load. This is our question. So first of all, you need to write the given data that include outer diameter, that is 200 that is you can write capital D or DO. Either you can write capital D or small letter DO. And inside the diameter is 150 that can be written as small d or di, and we have the length, that is L is given as 4 meter with n condition as both n fixed. So we have n condition for both n fixed. We need to find the effective length. If the length of the column is 4 meter, then if the both ends are fixed, then LE is equal to L by 2. We have an equation for that, effective length. So by doing that one, you can find that effective length LE will be 2 meter long. And factor of safety is given. After finding Rankine's coupling load, we need to divide that by 6 to find safe Rankine load. So factor of safety is given here. If the factor of safety is not given, you can directly say the determined safe Rankine load is the final one. Since here factor of safety is given, we need to consider that also. And crushing stress, that is sigma c, is given as 500 Newton per mm square, and Rankine constant alpha is given as 1 by 1600. These are the data given, that is outer diameter DO is equal to 200 mm, inside diameter DI equal to 150 mm, length L is equal to 4 meter, factor of safety 6, sigma c, that is compressive crushing stress, that is 500 Newton per mm square, alpha equal to 1 by 1600. First of all, we need to find the equation for Rankine constant, that is P. No need of PCR. You can write it as P itself. Sorry, no need of PCR. That is P is equal to sigma C into A divided by 1 plus alpha into L by K square, where L is the effective length. So first of all, you need to find effective length of the column. Just check the end condition. If both ends are hinged, then that will be L is equal to L. But here the question is given as both ends are fixed. So you need to take that condition, that boundary condition or end condition. For that, LE will become L by 2. So you need to consider equivalent length, that is L by 2 is equal to 4 by 2 equal to 2 meter. That is all dimension given in mm, so 2 into 10 raised to 3. After that, you need to calculate area of cross section, that is A is equal to pi by 4 dO raised to 4 minus di raised to 4. This is a common equation for hollow shaft. dO and di are known to us. After substituting this one, you will get 13737.5 mm square. Please write down all the given data. After that, we can continue. Please write down all the given data. Given that DO is there, DI is there, L is small L is there, factor of safety 6 is there, sigma C is equal to 500 Newton per mm square is there, and finally Rankine constant alpha equal to 1 by 1600. So please write down. After you have completed, we can go to next slide, or you can directly do the problem if you are capable, since you need to know what are the things. Sigma C is known to me, known to us. A can be found out using the relation of area, that is pi by 4 TO raised to 2 minus DI raised to 2 divide itself, and alpha is given in the problem. L is the LE, effective length, that is 2 into 10 raised to 3, and K should be find out. How to find K? That I will teach you, but if you know how to solve K, then you can directly substitute the value of K also. Just think the moment of inertia equation. Have you completed this slide?
ಮತ್ತೆ IA square.
Yes. I equal to AK square. So A is known to you. I need to be find out. For a hollow cylinder, pi by 64 into d o raised to 4 minus di raised to 4. So you can directly find the value. Have you completed this slide?
Yes, sir.
Okay, thank you. So after that, you need to find area of cross section. For that, we have an equation pi by 4 do square minus di square. After substituting the values of do and di, you will directly get the value of area. Don't copy the value. Please do it with your calculator. Then only we can understand the process. Use your calculator for finding the value. There may be error. I don't know. Is the values correct? Everyone should use calculator. Don't copy the slide. There may be error.
Area equal to അത് 13,744.5
ഈ എന്നെ കറക്റ്റ് കിട്ടുന്നുണ്ട്.
Okay, there will be change if you are taking pi as 3.14. Someone may take pi directly. So there will be small variation. Whatever you are doing, that answer should be taken as. That is, someone may get 13737 and someone may get 13744. So if you get 13744, don't think that it's wrong. It's actually correct one. So you need to calculate next step according to that value. Okay. So equivalent length should be found. Equivalent length is the LE, not L. Capital L they are using in the textbook. So you can use either capital L or LE. LE is equal to L by 2. Reason should be mentioned in the bracket because both ends are fixed. ഇതിന്റെ ബ്രാക്കറ്റിലായിട്ട് റീസൺ എഴുതുക both ends are fixed. Both ends are fixed. So we have the equivalent length as 2 meter or 2 into 10 raised to 3 mm. So after that, you need to find the value of k. As we have already mentioned, k is the radius of gyration, and radius of gyration known to you means you can find with the help of moment of inertia equation, that is I is equal to a into k square, or k can be written as root of I divided by a. Root of I divided by a. So first of all, you need to find the value of I. The equation for a hollow cylinder, I is equal to pi by 64 do raised to 4 minus di raised to 4. So you need to substitute the values, that is do is 200 and di is 150. 200 raised to 4 minus 150 raised to 4. So calculate the value. Use yourself, don't copy the values. There may be small difference if you are taking 3.14 as pi or pi as 22 by 7. That is direct value of pi is, you know that it's not limiting to 3.14. There is a additional points. In fraction version, you can say pi is equal to 22 by 7. That's the actual value of pi, 22 by 7. Are you getting this value?
Yes, sir.
Okay,
അപ്പോൾ
thank
കെ
you. So
62.5
no issue.
റൂട്ട്
That's fine.
62.5.
Root,
അപ്പോൾ കെ 62.5.
K value of K.
Ah,
Okay, this is the value of K. So substituting the value of I as well as A in the equation of K, that is K is equal to root of I divided by A, you will get root 536.62 into 10 raised to 5 divided by 13737.5. So after calculating this one, you will directly get the value of radius of gyration, that is 62.5 mm. Unit should be mentioned because there is a chance of error if you are doing a wrong calculation. And now you need to find Rankine's equation, that is PCR. PCR, we have an equation for PCR as sigma C into A divided by 1 plus alpha into L by K square. So you need to calculate this one. For that, you need to substitute the value of sigma C, A, alpha, effective length, and radius of gyration. What are they? Sigma C, A, alpha, effective length L, and radius of gyration K. After substituting this value, you will get the equation as such. Don't copy, please write down. If you have intermediate step, that is when you are doing, first point will be 2000 divided by 62.5. This should be calculated. Please show at least two intermediate steps or at least one, because bottom side and top side should be calculated separately. Then only you can find this value. Don't solve all this equation as a single equation in your calculator, because if you are not familiar with the calculator, there may be a chance of errors because you may miss some brackets and that will lead to errors. First of all, you need to calculate 2000 divided by 62.5 and it should be multiplied. After calculating the values, the square should be found out, and after that multiply it or divide it by 1600. After that add 1. After that 500 into this value should be multiplied. Divide this value with respect to the bottom. This is a step, and after that you will get the value as 41.88262 Newton. Tell me whether you are getting this answer.
sir, കിട്ടുന്നുണ്ട്.
കിട്ടുന്നുണ്ടോ? എല്ലാം ചെയ്യട്ടെ.
അത് 4185,157 അങ്ങനെ വരും.
ഓക്കെ, പൈയുടെ വാല്യൂവിലെടുത്ത വ്യത്യാസമായിരിക്കും. ദർ ഇസ് നോ അതർ ചേഞ്ചസ്. സോ പോയിന്റ്സ് എല്ലാം ഈക്വൽ അല്ലേ? അഥവാ ടോട്ടൽ വാല്യൂ അഥവാ 1 2 3 4 5 6 7 7 ഡിജിറ്റ്സ് തന്നെ ഇല്ലേ?
ആ ഉണ്ട് ഉണ്ട് ഉണ്ട്.
Okay, small variations, there is no problem. Also, we should be very careful whether our calculator in degree mode or radian mode. That may also lead to errors. Calculator എടുക്കുമ്പോൾ അതിൻ്റെ ഡിഗ്രി റേഡിയൻ മോഡ് ഉണ്ടാവും. You have to choose degree mode, else there is a chance of error. Okay, hope you have written this equation. After writing the equation, the question is to find safe log. save Rankine load. This is actual Rankine load. If the factor of 30 is not given to you in the problem, this will be the final answer and you have to convert it into kilonewton. Normally, we are keeping all the dimension in kilonewton. So this value, the final value will be 4188 kilonewton. That's the answer. But in the question paper, they have asked you to write the value of safe load. For doing that, you need to divide the final value, that is 418862 divided by the given factor of safety. Actually, the column is capable to take a load of. This is the practical condition. The column is able to take the load of 4188 kilonewton. But for a safety precaution, we are giving or allowing maximum 698 kilonewton to the column. More than 698 is not allowed to give to the model. Just think all the problem with a practical condition. We have different columns in our houses. Pillars are there for safeguarding or supporting the construction or floor or roof, everything. And for a long period, when we are applying a repeated load, that weight may be varied. If rainy season, there may be a chance of absorption of water particles to the roof material. So the weight of roof will be increased. So this load cannot increase the total load of total uh, resistive load of the column. So we should give some factor of safety to the material to withstand the condition. We have an example of Mullaperiyar Dam. The dam is capable to take a load of 160 meter height, but the maximum allowed height is 141 or 140 or 142 because there is a 18-meter gap maintained for the safety issue. So we have to give that factor of safety for all the construction, all the columns, and all the materials. If the person, the designer is instructed to do. So this is the method of solving a problem. So we will once again check the problem how we have done. The given problem is a hollow cylindrical cast iron column, 200 outer diameter, 150 inside diameter. Please be careful. If you missed anything, you can learn now. We have time. So 4 meter long has both ends are fixed. Just change. You have to do different problems. For that, you can change the values. Outer diameter can be varied, inside diameter can be varied, and length of the column can be varied, and both ends of fixed is given here. So you can take another example in which one end fixed and other end is free. And you can take another example that is one end is fixed and one end is pinned. So in that case, or in a fixed one end and free other end means the effective length will be 2 into L. That is, if the given problem 4 meter long column is given means your effective length LE will become 8 meter. Or in the case where one end is fixed and other end is hinged or pinned, you need to take LE as L by root 2. So L is given as 4. 4 by root 2 is will be the answer. And you know that 2 into 2 is 4. So 2 into root 2 divided by root 2. So final answer will be 2 root 2. That will be the effective length. And it is subject to a compressive load. Obviously, it's showing that we cannot neglect the effect of compressive load. So the column must be a short column or a medium column. In the case of a long column, the effect of compressive load will be very less. So there is a variation. And taking factor of safety, the factor of safety is given in the problem, that is 6. It's a very huge factor of safety. In most of the case, we will give 2 to 4 factor of safety. So considering the value of 6, it is a good factor of safety given and capable to take more load even though the maximum allowed stress is 500 Newton per mm square. That is, when we are calculating the crippling load, we will get 4188 kilonewton. So the column can handle that much kilonewton load, but the maximum load applying on the column is 698 only. After or more than 698, if we are giving, we are not allowed to do that. So there is a factor of safety. Then the Rankine constant also given. So if the Rankine constant is known to us, it's the alpha directly. And in the previous class, we have discussed what is alpha. And we have given two values of alpha, that is one for mild steel and another for cast iron. If if in a problem the values are not given and the material cast iron is only given, then you need to consider ranking Rankine's constant as given value in the last slide, and you have written in your notebook also. That's the important thing. Then first of all, you need to write the given data. After writing the given data, you need to write the Rankine's equation, that is Rankine's law. 1 minute. Okay. Rankine's law, that is sigma Ca divided by 1 plus alpha into Le divided by K square. So you need to find each term. Sigma C is given in the problem. A is unknown to us. Alpha is given in the problem. L is not given in the problem. K is unknown to us. So you need to find all the three values, that is A, Le and K. And area of a hollow cylinder is known to us as pi by 4 dO raised to 4 2 minus di raised to 2. So when you are solving that one, you will get the area directly. And when you are substituting equivalent length L by 2, because both ends are fixed, so that will be 2 into 10 raised to 3 mm. And you can find radius of gyration K using the relation I is equal to AK square. And I is equal to AK square, in which I is unknown to us. So first of all, you need to find I. Area is already found by the relation, and I can be founded using the relation that pi by 64 dO raised to 4 minus di raised to 4. So after calculating this one, you can get the value as 536.62 into 10 raised to 5 mm raised to 4. There may be small variation if you are taking pi as 3.14 and someone may take pi as 22 divided by 7. After that, you need to find the value of radius of gyration, that is root of I divided by A. And if you are substituting the value, you will directly get K as 62.5 mm. After that, we have the equation, the previous equation, Rankine's equation, that is sigma C into A divided by 1 plus alpha into Le divided by K square. So when you are substituting the values directly, you can get the Rankine's crippling load. And if you know the value, that is 4188262 Newton, you can convert it into kilonewton. That will become 4188 kilonewton. And you need to find state load by dividing crippling load or Rankine's load with respect to factor of safety, and you will get it as 698043 Newton, or in other words, 69804 kilonewton. എല്ലാ സ്റ്റെപ്സും നിങ്ങൾ എഴുതിയെന്ന് വിശ്വസിക്കുന്നു. വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള കാര്യമാണ്. ഇഫ് യു ഹാവ് എനി ഡൗട്ട് യു ക്യാൻ ഡിസ്കസ് നൗ, ബിക്കോസ് ഇൻ നെക്സ്റ്റ് ക്ലാസ് റൂം we will discuss another problem, Rankine's problem, and how that is related with the Euler's equation. That's an important thing. As we have already studied Euler's equation, you can use the same values. Please find out the value of Euler's equation. You know that if these values are known, you can find Euler's equation because Euler's equation, the only unknown is Young's modulus, E. We have the equation as pi square EI divided by LE square. Allah, that much is our equation. So you can solve the same equation. Please take a convenient Young's modulus. You can Google the Young's modulus of a cast iron. For a mild steel, the value is 2 into 10 raised to 5. But for mild cast iron, I am not remembering exactly. You can take a convenient Young's modulus. So you can do another problem with the same values and you can find the value. In another class, we will compare the equations of Rankine's equation as well as Euler's equation. This for today. Please put your attendance in the command window. Please put your attendance in the command window.
അപ്പൊ കഴിഞ്ഞ പരിപാടിന്റെയോ?
അടുത്ത പീരീഡ് ബ്രേക്ക് കഴിഞ്ഞിട്ടല്ലേ 2 മണിക്കല്ലേ ഉള്ളൂ.
കഴിഞ്ഞ പീരീഡ്
കഴിഞ്ഞ പീരീഡ് എനിക്കറിയില്ല. ഞാനിപ്പോ ഒരു അവർ എടുത്തിട്ടുള്ളൂ. ദാറ്റ് ഈസ് 11:30 to 4th hour. തേർഡ് അവർ ആയിരുന്നു എന്ന് എനിക്കറിയില്ല.
കഴിഞ്ഞ പീരീഡ് MF ആണ്.
MIF ആയിരിക്കും. I am giving this much time to learn this thing because this will be a sure question in your question paper. Attendance എടുത്ത് കഴിയട്ടെ. ഞാൻ മാർക്ക് ചെയ്യുന്നുണ്ട്. കുറെ പേര് ആബ്സെന്റ് ഒക്കെ ആവുന്നുണ്ട്. വെരി ഇമ്പോർട്ടൻറ്റ്. Five and 19s are absent actually. 5 and 19. That is Alan. And 19 who is
19% ആണ്. 19 കമന്റ് ഇട്ടില്ല.
കമന്റ് കണ്ടില്ല. ഒരു മിനിറ്റ്. സോ ശ്രദ്ധപ്പെടാത്തേക്കും കണ്ടു. Sorry. So 5 is absent. Please join at 2 p.m. exactly because we
Okay,
need
sir.
to do the another problem. That's very important problem actually.
Thank you,
Thank you,
sir.
sir.
Thank you.